Hi, my name is Brittany Jackson, and this is my Module 1 presentation for proportional and algebraic reasoning, specifically about integers under addition. Please excuse my voice is a little bit raspy. I am just getting over coming down with the vid, and I still have a little bit of a residual cough and irritated throat. A little bit of background about me. I have been teaching for 4 years. I've been teaching math, or I have been teaching students math, as we say at my school, for the past 4 years. I recently transitioned from the middle school to the high school level. So I think that a lot of the tools and strategies that we spoke about this week are definitely helpful for the grade level that I am currently teaching. So one of the things that I do strive for, not only for myself, but for my students as well in my classroom, is the use of clear and concise math language. This is a Common Core math standard, even though they use the word precise instead of concise. I really like the idea of saying what you mean in as few words as possible, and understanding the vocabulary and terminologies in math can definitely help with that. So one of the things that we went over in Module 1 this week is some of the basic properties of addition, the commutative, associative, and associative property of addition, also the concept of having an additive identity, and inverses and how they relate to opposite numbers or opposite integers. I am normally a person or a teacher that feels like the conceptual understanding is more important than the actual vocabulary. And even though I still believe that, I definitely think that the use of the property names not only helps students clearly and concisely explain their mathematical reasoning, but I think that it also makes math real. So if you can find examples of when you use the additive identity, for example, like a buy one get one free deal at the store, right? You bought something for a price and then you got an additional item for zero value, right? For no money. So understanding that in that instance you use the additive identity really brings math into the real world. And whenever you can do that, I think that you kind of are able to overcome those questions of when are we ever going to use this in real life. So I think that having those clear and concise definition and properties in your back pocket can be helpful not only for student engagement, but for helping students explain their math reasoning clearly and concisely. One thing that I've heard from many, many math teachers that has definitely been a struggle for me is the idea that you should not say that you're canceling things out in algebra. That is the way that I was taught, and even though the term of zero pairs is not something that is new to me, it's not the first time I heard it, it's definitely been a while since I've put it into practice, or have even thought twice about using it. So this module definitely brought that back into my more recent memory, and this is something that I do want to incorporate more readily in my algebra courses. Sorry. So instead of saying that numbers cancel out, which kind of implies that they just poof and vanish, they disappear, which they don't, right? Instead, we can use the term zero pair so that these numbers create a zero pair. Not that they cancel out, the numbers don't disappear, but they create something that has no value when added together. And because it has no value, it does not add value in the equation that we are working with, right? So we can kind of see, and I want to use the word ignore, but that's almost as bad as saying cancels out. But we can act as though it doesn't have any value, and we can almost like set it to the side. I think I have to put a little bit more thought into it because I don't want to say the word ignore. We can't ignore a zero pair, right? It still exists. It just doesn't add any value. So I will think more about that, and that is something that I'll continue to think about. But yes, just using the terms zero pair instead of canceling out when we're talking about, especially like inverse operations when we're solving for a variable. And even like in basic addition when we're adding 4 plus negative 4, understanding that not only are those inverses, but that the definition of inverses is that when added together, they create a zero pair. In this module, we also talked about how we can teach the addition of integers. Some of the examples or strategies that were talked about this week were using manipulatives, yellow and red manipulatives to represent positive and negative integers, and also the idea of teaching integers using elevator buttons. And those are really great strategies at an elementary level, but one of the ways that I like to teach integers at a higher grade level, especially at the high school level, when students are getting jobs, they're really into purchasing things and having things that cost money, is using money instead of manipulatives. I just think that that is a better, it more connects with their real world experiences, just like an elevator would connect with the real world experience of an elementary school student. So I really like the idea of using money. It also, in addition to being a math teacher, I also teach a financial literacy elective. So introducing the vocabulary of debt and income is really near and dear to my heart, and teaching that, positive numbers could represent money that you have coming in, money that's being added to your account. Negative numbers represent debt, money that you owe other people, and how kind of the net total of what you have versus what you owe create net worth, and in terms like that really bring in the teachings of financial vocabulary, which is something that I think needs to be taught more in schools. And last but not least, the use of number lines I also find really helpful when teaching this concept. I always use the term bunny hops, where we count bunny hops, even at the high school level, even though that sounds super elementary, but always the idea that we count bunny hops, so that way students don't count dashes or lines, because they'll always be off by one, and that moving to the right on a number line is the same as adding, moving to the left on a number line is the same as subtracting. And if a student has a really good foundational conceptual understanding of the number line, then that really helps them to mentally visualize where you will end up when you take a certain number of bunny hops to the left or the right of a number. That is my total presentation. I look forward to seeing what you all have come up with and what strategies you have learned and gained from this module, what strategies you will be incorporating or do incorporate currently in your classrooms.